delete it. And if you record with this one, the recording is not exactly by mm, not exactly like it's not mp4, it is a webm. So the YouTube can understand, but other playing will not understand. Okay, whatever it is, we started recording. Now we discussed about what is a network, what is networking, internetworking, types of networks, default gateway also we discussed, and how we are connected, like this also we discussed. Now the point is requirement to create a network. Okay, there is a few important points are there, guys. I am telling now only. Just I already shared this PPT to your WhatsApp, so then better to go that one. Important things are OSL layers, IP addresses, OSL layer, IP addresses. In that one, OSL layers, it is there is a protocols and devices. Okay, if you want, I will give you one overview part also. Yeah, I will give you one overview part, very easy, like a revision type. In a network, we use a different type of networking devices. Okay, different type of networking devices. Very important devices are like a hubs or switches, bridges, routers, modems. The networking devices: hub, router, bridges, bridge, router, hub, switch, router, hub, switch, router, then modem. Bridge is optional, repeater is optional. Okay, not very, very important. Okay, so simple terminology to understand: hub used for LAN communication, small networks. Okay, we use it small network, LAN communication network. Switches are basically switches are used for LAN communication only. LAN communication, and you use for a small and large networks also. Large networks, small and not. It is intelligent. It can understand MAC address, so it will do MAC learning and MAC table. It create a MAC address table. Okay, it will MAC learning. That's we'll review that one. Some points are there, so but we need a quick review. Bridge is not really Bridge is not really a device. Not really a device. It is a software based. Exactly say it is bridging to networks like a router type or two NICs. Bridge between networks or NICs. It's a bridge part. Router, it is we use for a WAN communication, both LAN and WAN communication. Both LAN and WAN communication purpose. Okay, internetworking device, internetworking purpose we are using. Okay, so router is for LAN and WAN internetworking device it is. And one more is there about a router. It is follow a routing, so it means it shows best path to reach destination. Shows best path to reach the destination. Okay, what is the part of modem? It connects to internet. Want to connect to internet? So we use a modem through, or you can say, or we can say, first of all, it connects to the internet, or it will connect to our ISP, Internet Service Provider. If you connect to ISP, then only you will get internet, right? So it connects to the ISP or it connected to internet. So both statements are correct. Okay. Actually, modem is the word came from the modulator and demodulator. Okay, a modulator and demodulator. So it make a communication LAN to your local network to public network. It is your local network to your public. So we need a long distance communication. Okay, long distance communication. So it very simple. It connects through. It connect. You use telephone wires. It connects to internet or ISP using telephone wires. Olden days we use a telephone wires. Now we are using fiber, optical fiber network. Not optical fiber cables is correct one. Telephone cables are a optical fiber cables. Very simple, one word, guys. There's deep explanation is also there, but better to have a simple explanation. So later we will go. If you have a time, then we can go for it. So hub is a very used for a small. Hub is used for a small network, and it is a used for a LAN network. Now, what is this repeater? The repeater is used for a repeat the signal to communicate long distance. Okay, so we use the repeaters to communicate long distance because of generally our cables support 100 meters, but 80 meters, 100 meters we reach signal is very weak. We use a repeater. It repeats the signal. It don't boost the signal. It repeats the signal so then we can reach another 100 meters. Okay, so hub is act like a sometimes hub is act like a repeater. Okay, so there are the mainly four important device: hub, switches, routers. Hub, understand, it's a LAN network, small network. It's a layer one device. It is a layer one device. This is layer two device. It is layer three device. Okay, yeah, of course there is a lot of devices also available. Different things are there. So of course we can put it in a line also. Okay, these are all security, connectivity. There are a lot of things also available, but I am telling only main direct points. Okay, there is a gap also. By gap, I think I created this gap. Yeah. Okay. Next one is this is a basic importance of your devices. So here from here, the each device's explanation is there. Okay, hub or a repeater. So this is the hub. When you type a network hub in the Google, then you can also get this picture by showing how it is function. It is not an intelligent device. It does not understand MAC address or IP address. Okay, it does not understand MAC address or IP address. Hub used at a LAN communication. It is a layer one device. Layer one device. Okay, the repeater repeats the signal. Also, hub is also used for a repeated. It's suitable for a small networks. So why? Because of, so see this is the hub, and these are the devices. When you are connecting the devices to the hub, what will happen if A is communicating to C? A is communicating to C. So what happen? A send a packet to C. The packet to go to the hub. Hub would broadcast to everyone. Hub broadcast the packet to everyone. So B received it, C received it, G received it, and of course B received, C received, D received, and C received. So where it is happened? A, B, C, D. Instead of E, I put a G. Okay, now all. Okay, this is APC, BPC, GPC, DPC, CPC. A to C communication. A send a packet to A is try to send a packet to C. So then what happened? It packet go to hub distribute that packet, means broadcast the packet to everyone. So by because of that broadcast, lot of traffic is generated. Everybody received a packet, and they check it is belongs to them or not, and they drop the packet. They drop the packet, and C received a packet, then accept the packet because it understand its packet is belongs to it based on the source IP and source MAC address. Okay, it confirms it is taken. But for every time B is trying to send a packet to C, again packet go to hub, broadcast the packet to everyone. For example, C tried to send a packet to D. Packet went to the hub distributed the packet to everyone. So this is like a only broadcast. It only broadcast. So the number of collisions will occur. So lot of packet loss is possible. Okay. Here the point I given for a repeater, guys. Wi-Fi extender is one of the example. Why there is a repeaters are there in general. Wide repeaters also there, but in general nowadays, if you people ask, give me an example of repeater. So you can say Wi-Fi extension. Nothing will change. Only signal will boost for little longer time, right? So this is about a hub. This is about a switch. Switch is an intelligent device, okay, and it is understand MAC address. Switch create a address table like this. Switch create a table that is called a MAC address table based on the PCs those who are connected to this. Switch is connected to the PCs. When these PCs are communicate each other, initially it is broadcast, but initially initially there are broadcast each other. So then, so initially the packets are broadcast, but switch learn the MAC addresses of the devices like PC A, PCB, PCC. Each PC having an IP address and MAC address. So when they are communicating, so our switch create a table. So port numbers of a switch, and MAC address of the device. It create a table. So what is the advantage of this table is, for example, someone is send a packet to 6 1. Where is 6? Here it is a sixth one. So A send a packet to E. So now no need of broadcast. It will send a packet to this 6 port only. For example, this PCD is send a packet to PCC. Okay, so the destination MAC address is 1C. So packet is sent. So check the packet. So destination is 1C. Where is 1C is located? Port number 3. So it will forward the packet to 3 and C receives. That is how switch works. That is how switch works. Okay, it is not like that. It don't it initially it will broadcast for a learning MAC addresses, but later it will create a Once it is created a MAC address table, it use the MAC address table to forward the packets, forward the packets like a unicast. So again, switch is used at a LAN communication. Switch is a layer 2 device used for small and large networks. Large number of devices also we can connect it because of switch having a multiple ports like this. Number of collisions are less. Why? Because of MAC address table. So less packet data loss. Some people ask, what is a layer 3 switch? This is a switch means layer 2 only, which is belongs to OSI data link layer. As per OSI layer, layer 2 device is switch. But some people will ask like networking. So then what is a layer 3 switch? Layer 3 switch is function like a switches and router. Both functions are there. Layer 3 switches having a switch function and router function. Both functions are there. It act like a switch, it like a router. And also mainly for it is a kind of inter-network communication. So inter VLAN routing concept we can able to implement on a this switch cum router layer 3 switches used for a inter VLAN routing. Okay, there is a big concept is there, so we don't go for that one. What is the function of switches? MAC address learning, forwarding the packets. Okay, so there is another information, guys. Switch is an intelligent device. Switch understand MAC address and it create a MAC address table using a MAC address of the devices, MAC address of the devices, and port number of switches. Okay, switch used for LAN communication. It is a layer 2 device used for small and large networks. Number of devices, large number of devices we can connect because of large number of ports are there. Number of collisions are less because of MAC address table. So obviously less packet data loss. So here is some difference between switch and bridge kind of stuff. Bridges are software based, less port numbers. Basically, how many NICs are there? Maximum that many bridge ports we are getting. Okay, this bridge is not exactly a physical device. It is switch is not like which is a hardware device. Which is having more number of ports. Switch bridging is the only concept like logically we are able to connect different topologies or different connections. Okay. Next important device is a router. Router is a intelligent device, of course. Router understand IP address concept, right? Logical address. Okay. So router can understand IP address. Router is a layer 3 device, OSI layer 3 device. It's called a network layer. So router used for both LAN and WAN communication, both inside communication and outside communication. Router is a inter-networking device. Router is a inter-networking device. It means it connects two or more networks together. Okay, two or more networks together. What is a router? Router is a inter-networking device, layer 3 device used for both LAN and WAN communication. Router can understand logical addressing like a IP address. It will understand. Okay, so here a small part. What is the meaning of route? Route means path, right? You want to go somewhere. You want to you want to know how to go, right? That is called route. The way you go, that is called route. It is also we can call it as a path. What is a router? Route means path. Router means the device which shows the path. The device which shows the path. Router means which shows the path. The router shows best path to reach the destination. Routers use the routing tables to know how to reach the destination. So how router knows how to reach the destination? I'm here. I want to reach google.com. How I know how to reach the destination? How I know how to reach the destination? So I forward my packet to router. A router knows how to reach the destination. So how router knows? Based on some routing protocols. So again, same thing only. So routing tables are created by manually called static routing. I have a 10 routers are there. Each router is connected to different networks. So I go to each and every router. Manually, I configured the path, how to reach the destination path in the router. That is called a static routing. So that is little burden, but it is more advantageous than other things. Okay, it is more priority than any other routing part. Okay, so then here it is. Static routing means manually configuring a router for a defining a routing paths in the router. Okay, so what is this dynamic routing? Dynamic routing means we implement a routing protocols. We implement routing protocols on the routers. Using these routing protocols, automatically routing tables will be created. These paths are created automatically in the router using these protocols. So what is this protocols called? This is called dynamic routing. The dynamic routing protocols are IGP, EGP, interior gateway protocol, exterior gateway protocol. Means it's inside autonomous system, outside autonomous system. That is the wording is again very big one. So don't go for that. So only names I'm telling. RIP version 2 means RIP version 2, IGRP, EIGRP, OSPF. So these protocols are IGP protocols, but RIP version 1 we are not using on the new routers. So then I didn't put it. IGRP also not using in the certain routers. Means very old routers we use RIP version 1, RIP version 2. It has their own disadvantages and advantages, but we are going with the now RIP version 2, EIGRP and OSPF. Okay, these are the interior gateway routing protocols. Out of these protocol, EIGRP is the best protocol as compared to RIP version 2 and OSPF. Enhanced interior gateway routing protocol, open shortest path first. Okay. So depends upon the organization they use which protocol they want to implement, they will implement. So we don't mind it. EAGRP, exterior gateway routing protocol, means it's outside of organization when you are communicating from one autonomous organization to another autonomous. So we need a EGP. So one of the main protocol is BGP, Border Gateway Protocol. Another protocol is ISIS. This ISIS is a very old protocol, and actually now it is implementing from last 5 6 years. ISIS is also implementing. Old protocol it is stop implementation. Now it is implementing in a new routers. Okay, intermediate system. Don't think it is ISIS. Okay, it's not that ISIS. It is ISIS means intermediate system. Intermediate system. Okay, so these are the main devices. But one more is there, no modem. Again, already I explained in one line, but we'll go thing, guys. Why I'm explaining like that? For this is only example explanation. Point is when you are learning something, the first one is quicker, basic lines or words. Then go to depth. Never go to take one router. What is the router? That what is the history of routers and all? You studied all the things, but you don't give it time to study other things. Okay, so at least you need a basic information. That's why I told about the devices and then I explained those devices. So what is a modem? Modulator and demodulator. Modulator and demodulator. Okay, modulator and demodulator. So what is a modulator? For example, here in this example I given, FM radios. Lot of people know FM radios. Lot of people don't know AM radios. All India radios are there, no? Like AM radios, shortwave radios. People don't know. All India radio is a AM radio. So later FM radio came. FM radio, the in India the frequency range is 88 to 108 frequency, megahertz frequency, not smaller frequencies. Guys, when I'm speaking, my voice level is 20 to 20 kilohertz maximum, and my hearing capacity is also 20 to 20 kilohertz frequency. Any audio signal with a 20 to 20 kilohertz frequency I can able to hear. If it is lower or higher than this range, I cannot hear. Higher the frequency, longer the distance we can communicate. Okay, that is also one point. Okay, next, what is this FM radio part? Why I am telling this one? Our voice levels means volume, pitch, frequency, what are the word we use it, that is limited. So you want to transfer your voice or a data to long distance. So what the people do it in a frequency modulation, FM radios, they add this signal to the high frequency signal. Example 104 megahertz signal, channel number 104, 93.8, 93.8, 98.1, 95 point something. There's no radio Mirchi, big FM is not there. Radio Mirchi, 104 fever is there or not, I don't know. That's 104 fever. The channel name is 104 fever. Radio Michi, Red FM. So there's channels are there. No, they will tell their frequency 98.1, 95.3, okay, 93.8. These are all different frequency channels, right? So what they will do? What are the thing is there? 98.3 radio Mirchi means 98.3 megahertz high frequency signal. They'll add this our regular signal to it. That is called a modulation. Once you modulate the signal through the towers with high energy, they will transfer it. Okay, they will transfer it instead of us putting a very big loudspeaker to transfer the signal. Instead of putting a very big loudspeaker, they mix in the signal and they will forward. So people, those who having a FM receiver and tune to the Butler signal like a 104 megahertz or a 98.3 megahertz or 95.3 megahertz or 93.8 megahertz. Okay, so whenever they tune to the Butler signal, so they can receive the signal, and the original signal will be this high frequency signal is filtered, they'll get a original signal. So this is called a baseband broadband signal communications. So what is the baseband means? Original signal. So modem converts baseband to broadband. Very simple one statement. Modems make you connect you to ISP. Because of whenever it is connecting to ISP, the ISP will give you internet. So modem makes you connect to ISP. Modem connects to internet. Modem modulate and demodulate means generally our LAN network is a digital based signal network. It converts into analog signal. That analog signal can be converted to signal NAL. So I done a spelling mistake. Single I written single, not single guys. Digital signal, not single signal. Okay, I will modify it. Okay, careful signal. Um, maybe your data should be transferred to telephone lines. Okay, or maybe data we want to transfer to fiber optical lines. So compulsory data should be conversion may they required. So we use a modem. Also modem make a connectivity. Nowadays we are getting a Wi-Fi routers in home. Wi-Fi routers. It is router cum modems. It is a router cum modems. And I given these two extra points here in down. It is router cum modems. So you don't may seen a separate modem there, but it is a mixture of both modem and as well as your Wi-Fi routers. Some places it is different. Like we have taken new broadband, that is a modem is separated, Wi-Fi router is separated. Okay, router act like a default gateway. Router IP address is default gateway IP address. That point I should be added there, but I added here. Okay, whenever you're communicating outside of network, you need to send packet to default gateway separately. I have to separate these things instead of that one it is mixed. And also there is a few more things like what is a wireless access point, what is a Wi-Fi router, what is a home internet router, what is proxy, what is firewall, what is VPN. So find out all these things information also. Okay, already I explained this small home small office kind of stuff, but little different guys. It is a router and a modem is connected to ISP, but internally you can see this is a router, this is a switch is connected, the devices are connected to the switch is connected to the router, and we can send a packet through router to the internet. But in your home, for example, in my office I have a wireless devices and wired devices also there. So what I have to do, wired devices, we have a switch, we can connect it through wire. I have a wireless devices. I have a wireless devices are there. Like a laptops, mobile phones, tablets are there. I want to connect it. So then I use wireless access point. Wireless access point. What is the wireless access point? To connect the devices. To connect wireless devices. Wireless access points are used for connecting the devices. Wireless devices. Like a switch is connecting wired devices. Wireless access point connect a wireless devices. For example, you combine wireless access point plus router. You combine wireless access point plus router. It become Wi-Fi router. Router is interconnecting device. It make a connecting from inside network to outside network, and you combine this wireless access point to your router. That's it's become Wi-Fi router. You combine your modem, router, and wireless access point. Then it what that is your home Wi-Fi router. The combination of wireless access point, router function, and a modem function in a single device is our home net home router device, home router, home modem like that. You can see. Okay. So it's some diagram I have given earlier while I am explaining. I've used this one. So you know the default gateway, where the default gateway is located. Also we know it. Okay. So these are basically some devices. But guys, some research on a means try what is a proxy, VPN, firewalls also. VPN is also one of the most common question. So these are all devices. So important devices: hub, switches, routers, and modems. Okay, these are the main devices. Of course, wireless access point, bridges, repeaters. Okay, these are all your devices only. Default gateways are also very important. Okay, with up to now, guys, devices are okay. Tell me, Nopal. Okay. Next part, I'm jumping directly to the topologies. Okay. So because we'll put a more, I can get a more little more time on a IP addresses and OSA layer explanation. Okay, and of course, anything is left for a part also we'll try. Okay, in between this OSA layer is also there. Okay, but small things we'll complete it first. It is important, at least you should know the names and one or two points of use how it is look like. That's it only, not required depth knowledge on it. That is a physical topologies. What is a physical topologies? The way of devices connected physically. I have a two computers. How I take a one wire, I connect two devices, right? So there's a possibility, right? Lot of possibilities are there. I have a computer and I have a computer. I take a wire and connect. This is the way of connectivity. Or maybe I take a one hub or a switch. I connect like this. This is the way of connectivity. Or maybe I take a one single wire. I made it connect like this. Okay. So this is also one connectivity. The way of you are connecting the devices, we call it as a physical topologies. Then what is this logical topology? So why logical topology is there? The logical topology defines the addressing of devices. It define the logical network. Logical topology define the network. Like, for example, based on the IP addresses, it defines the network. It defines the network based on the IP addresses. Physical topology defines based on the connectivity. Logical topology defines the network based on the IP address. For example, based on the IP address, this PC, this PC, this PC, these three PCs are same network. I have another two PCs. These two PCs are not in this network. There are separate network. All are connected same. All are connected to network. All these pieces are connected to a network. All are physically same network, but logically different networks. So when we are discussing about IP address, we will discuss about this logical part also. But again, what is the physical topology? The physical connectivity of the devices. The way the physical connectivity of a devices. What is a logical topology? Logical topology is it defines the network based on the IP address or IP network configuration. Okay, so here I have written little different. The way IP configuration to communication. That is also okay, but now I got a one good line, that is logical topology will be defined by IP network or IP address network. What are it is? What is the different type of physical topologies are there? So some are named. This is the first four names plus hybrid is actually important. These are all additional later. Okay, bus topology, ring topology, mesh topology, and star topology. This is the bus topology. There is a backbone wire. Okay, here it is. You have a backbone wire. Devices are connected to this backbone wire. I didn't speak about cables, right? So then, if you are using a coaxial cable, olden days, we have a cable TVs. Now we are having a dish TVs. In olden days, we have a cable TVs. Through cable only they will connect multiple things. So they have a one main wire. From the main wire is connected to multiple TVs. Okay, no channel management. It is all what are the cable guy give the channels. We'll get it. Okay, not much very digitalized. It is pure analog type transmission. This is the same concept. Is there is a big wire is connected, a backbone wire, it is connected to all the devices. It is very simple, very easy to configure, very less cost. But there is a problem. If in case if this wire is broken at some point, so the communication will stop between the one side devices to another side devices. Okay, so that is a problem with the bus topology. What is this? This is a bus topology. Devices are connected to a backbone wire. Next one is ring topology. You can put it any which ways, no problem. In a ring topology, actually people draw a circle, but I'm not drawing a circle. The circle drawing will kills the concept of ring topology actually. To represent it is a ring, so they'll put a circle, but in generally, so the ring topology is nothing but one PC, one device is connected to another device, and another device is connected to another next device, next device, like this. The devices are not connecting each other. A device is connected to the next device, and that device is connected to the next device, and finally last device is connected to the first device. So then it is form a circle or a ring, and it will works based on the protocols. For example, you take this the APC, B, C, D, E. You want to communicate to D. So then packet sent to B, B send a packet to C, C send a packet to D. Okay, not A, E, D. A, D, C, A, B, C, D only. Okay, if D want to communicate A, so how it will communicate? D send a packet to E and E send a packet to A. It means it is either clockwise or a anti-clockwise. Okay, clockwise or a anti-clockwise. For example, C want to send a packet to B, C to D, D to E, E to A, E to B. So traveling of packets are become difficult, and it is very difficult to scalability. Means if you are try to add a one more PC, again you have to change entire connectivity structure, algorithm, implementation. So this is a difficult to scalable, very long distance communication. And of course they find a solution for that one. That is, they connect a reverse side, A to E, E to D, D to C, C to B, two paths. So in one path, A B C D E communication, in another path, A E D C B communication. Okay, so two paths, like if in case I want to send a packet from C to B, like I will send packet like this. So based on the algorithm, it works. I want to send a D want to send A want to send a packet to D, A to E, E to D. So both clock and anti-clockwise working is there. So that is called a double ring topology. Okay. So then it made a one problem solved, but another problem is not solved. That is called a scalability. Number of devices increases. There is a lot of challenges. Okay. So this is called a ring topology. Next one. If anybody guess this one, I will try. We'll see. Anybody guess which topology it is? Start. Very good. Very good. I'm always feel happy when I hear that answer. That's the difference between academies and textbooks, kind of stuff. So, guys, it is look like a star. Why people are drawing a star? To make it drawing very easily. It is actually mesh topology. So when you see a star, then automatically we think it is a star topology. Now, guys, it is mesh topology. Meaning of mesh topology is each and every device will connect each other. See, A is connected to B, A is connected to C, A is connected to D, A is connected to D also. For example, you take a right? It is E. Okay. For example, you take a D. D is connected to E, D is connected to C, D to B, D to A. Means each and every device is connect each other. Okay. It is highly redundant. It is a complex, highly redundant, um, and it is not scalable. What is not scalable means you put one more device. Again, how many devices are there currently? Those many connections you have to create. So connect like this, connect like this, connect like this, connect like this, and connect like this. It means entire wiring is demanding. So compared to number of devices in the network, but number of wires are more. The clumsiness of wires increases. Okay, it's difficult to troubleshoot, but it is very highly redundant. What is the meaning of this redundancy? For example, if wire is broken here, we can't able to communicate further, right? If a device is down, we can't able to communicate further if it is a single ring. Double ring is little okay, but in a single ring, so maximum we cannot able to communicate further. Okay, one side of communication will be stop at least. Okay, but here it is. If this wire is broken, no problem. Only A to B communication stop, but remaining communication go on. For example, DPC is down, no problem. A, B, C, E are communicating each other. If device is down, a device is down, no problem. Other devices will communicate each other. A wire is broken, no problem. All other communications will go on. Okay, that's it is. Mesh topology is a highly redundant topology, kind of, but more complex, more headaches. Okay, more analysis, very difficult to scale. When I was engineering in diploma, we don't have networking because my diploma is biomedical diploma. Okay, engineering is ECE. Okay, so um, I thought this is the mesh topology is a star topology. I learn from outside also. After engineering only, I realized this is a mesh topology, not a star topology. Only people draw like this for easy to draw. That's it. Okay. This is the star topology. So people will confuse again. I'll put a this side star topology. So last time in a one class, I asked why people say this is the star topology because star is like a sun, right? So sun light is there, no? So it is spreaded to from center to outside, like that symbolic representation. Okay, this is bus, okay, we can understand. Ring is okay, we can understand. Mesh is okay, we can understand. It's not look like a star, right? This is look like a star, this is not a look like a star. But point is it's the center. Star is in the center and it is give light out, right? So that is otherwise sun topology or star topology, moon topology, whatever. Guys, in this one, we use a centralized device. Either it can be a switch or it can be a hub. You can use switch or a hub as a centralized device. Devices are directly connected to this one. Okay, devices are directly connected to this one. This also some advantages. For example, if this wire is broken, only a PC cannot communicate. Other PCs will continue communicate. If in case centralized device is down, mean the switch is down, total communication is down. It is very easy to configure, little costly. Why? Because we are using additional device, but it is a scalable, easy to configure. It is scalable and it is easy to troubleshoot. Compared to all others, it is easy to troubleshoot. What is the meaning of scalability? So, what is the meaning of scalability? I have another network, for example, I have another switch or a hub, and there is a devices are connected. Okay. Now, if in case I make a connection from here to here, so what happened? This is the network. This is the another network. Now it is become single network only. Like in our office we have a switches. Each switch port is 24 port switches. 24 port or 16 port? I didn't remember. 24, I think. 24 port switches are there. So we have a 3 24 port switches. So almost like earlier, we got almost more than 60 computers are there. Almost around 60 computers. Around 60 computers are there. Okay, so one room 30 computers, another room around 25 computers, plus other rooms one system for a front office, back office kind of stuff. Okay, so mostly like it is around 50 to 55 computers are there. Now it is reduced. They remove some computers, and only we are using now 30 computers. 30 plus computers. 24 124 switch cannot support more than 30, right? So more than 20 to support, more than 20 22. Okay, but you should not cross more than 24, right? So how it is possible to all connect all these devices together? So I use a two switches. So two switches means 20 plus 20 40. So 30 computers we easily connect. You got a more computer, then I will use another switch. I got another 20 more computers. No problem. I have another switch. I connect one switch to another switch. I'll create a larger. So this is called a extended star. This is called a scalability. Scalability means able to expand. Able to expand is called scalability. And this is called a extended star topology. Okay, but compared to star topology, mesh topology is highly redundant. Means if a device or a wire is a broken or a down, no problem, all are communicating each other, but it is very difficult to scalable. Okay, and it is complex. Star topology is not a complex. Star topology is depends upon centralized device. If centralized device is down, entire communication stop working. Okay, and it is easy to troubleshoot because we can easily identify is a virus problem or a device problem or centralized device problem like a switch or hub problem. We can understand with a simple star topology, and it is a scalability. And we are using star topology. We are all using star topology. So when I started with a different type of networks, there is a SAN network is there, a storage area network, means high storage data related things, server side server environments, core networking environment. They use mesh topology. Why mesh topology? For redundancy purpose. If one router is down, no problem, other router is automatically understand, it start giving the paths, or it start doing the packet kind of packet switching kind of stuff. Okay, or storage is also there. One switch is down in the SAN storage, one switch is down, no problem, the another connectivity to through another switch, they can able to access the data. Okay, that is a mesh topology. Star topology. If you combine mesh and star, it is called a hybrid topology. If you combine mesh and star, it is called a hybrid topology. Then what is the point to point? Point to point is if you connect a device to any other device, with a wire. So that is called a point to point. If you connect a devices to a single device called a point to multi-point. Like there is a router and there is another router. One router is connected to multiple routers is also called as a point to multi-point. One switch is connected to multiple devices, point to multi-point. A device is connected to the switch, point to point. A PC is connected to another PC, point to point, like this. Okay. Last topology is a tree topology. This is a man-made tree policy type only. All are man-made only, but these are the standard what I learn in my academies and later in a CCNA part. But some are asking what is the tree topology. The tree topology, why it is making a noise, that is connecting and disconnecting noise. Am I recording or not recording? Oh shit! No, 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 no. I am recording. Sorry, I am recording. I am recording. Sorry. Okay. The last part, guys, tree topology. Tree topology means it's a hierarchical topology. There is a core router is connected to distributor router. Distributor routers are connected to access routers. So in that case, it's a we can call it tree topology. This is a newly made. You can try in Google also what is a tree topology. Okay. Recently, people are inventing these kind of tree type of structures. Okay, trunk. Yeah, like a branches trees, one to another connection like this it is. One is connected to another one is connected to another one. Okay, or a backbone is connected to multiple things. Tree. Okay, so even it is not having any tree topology earlier, now this kind of stuff came. Okay, so not advancement of technology, just they want to put a name and it has become popular. So because last time also I verified through, because out of this one which one is correct one is showing like this. One is connected to two or three or four, and it is connected one two three four, but also it is showing like this. So one backbone is connected to multiple branches kind of stuff. Here it is common like this also there. Okay, so it is like a people are created or I don't know, but tree topology there is a main core system is connected to multiple system to subsystem. Of course really tree topology is there, but what is not there, but it is existence, it's kind of existing type one. Of course it's an explanation of bus topology. What is a bus topology, what is a ring topology, what is a mesh topology, what is star topologies. Okay. What is this is always remember part. We are all using TCP/IP protocol suite, not OSI, not SPX, not IPX, not Apple Talk. Okay, we are all using TCP/IP protocol suite only. We are all using IPv4 and IPv6, but majorly IPv4 based network only. Some people are, the people don't know anything, so obviously they will put a something on it, something. Okay, uh, lot of people say like we are still using IPv4. There is a Japan or Germany using IPv6. Then why America is a highly developed, so world powerful country in the world is America, right? But America is also using IPv4, not IPv6. Russia using IPv4, Australia using IPv4, right? They can enforce other countries use IPv6. Don't use IPv4. They are also not using. Some countries within the inside a communication they are able to develop a IPv6 newly formed governments, new technology accept or the router switches they can able to change it. The size is smaller. Another is smaller the size. Okay, of course. In India also, IPv6 is we are using in the mainly mobile networks or a private company internets. For example, Geo use IPv6. Okay, Geo use IPv6. Okay, for a customer communication or within that network only. But global network, entire network you want to communicate, that is only IPv4. Still IPv6 is going on. It take time. It's not depends upon India or it is depends upon the entire world. We use the star topology. We use star topology, TCP/IP protocols, IPv4 and IPv6. Out of that one, IPv4 is very important one. Yeah, don't worry. I'm not going with IP addresses. To next class, I will tell about that one. Yeah, this is about a star topology. How much time we have? Two things we are, of course, three things we discuss. One is a network and type of networks, devices used in the networks, and topologies. So, anything default gateway also we discuss. Yeah, this is we have to discuss, guys. That is cables and NIC. Both are we have to discuss. Then it will complete lot of part because tomorrow is no class, maximum no classes. Okay. I will inform whether if I want to put it in the morning, and I will inform that one. In generally, tomorrow is not there. Next Saturday will be there. Tomorrow, no, not there. So compulsory study, guys. Not no relax. No one knows when is your version test or when is your interview part. Okay, so compulsory study well. If you want any material, I can able to provide a continent. You can search and you can watch anything. So there is a campus 2 batch. There is a batch called a campus 2 batch, C2. If you go to the part like this, you can find C2 bracket, in brackets there is a C2 part is also there. So that is, I'll show you that one. Okay, so this is a N4. N4 is also okay, networking side and others. This is C2. In C2 also I put a lot of things. I've taken almost more than 1 month for this batch. Okay, so you can try if you want about Outlook or all kind of stuff. You can try and get it that information. Also. So keep learning. That's my suggestion. Yeah. Just hardly we have a, of course we have a lot of time. What we do? Yeah, take a break, guys. Small break. Just a 5 minutes break. Okay, and I will explain about NIC and cables. These two will finish today. Only left over is IP address, protocols, OSL layer. Main these three parts will be left over. We'll take care on that on Monday. Okay. So after break, I will go into NIC and media.